If there's one question I get asked more than any other as a chemistry teacher, it's, can I go to the toilet? And to be honest, I normally say no, because I think students should wait. Sometimes I might say, well, if it's a wee, you can have 2 minutes, or a poo, you can have 3 minutes. Anyway, a question I'd rather be asked is, how do you calculate relative atomic mass? So you might see in the periodic table an element like this, and the relative atomic mass is shown at the top, for example, as 35.5 for chlorine. And you might think, well, where does that number come from? Does it mean that chlorine has got 18.5 neutrons? Because we know chlorine's got 17 protons. If we do the mass, take away the protons, that gives us the neutrons. So do we have 18.5 neutrons? Well, no, because it's impossible to have half a neutron. And maybe if you've looked at really technologically advanced periodic tables, like my personal favourite, the Royal Society of Chemistry mobile app periodic table, it will show it like this. It will say oxygen has a relative atomic mass of 15.999. And again, you might think, well, does that mean that oxygen has 7.999 neutrons? To which the answer once more is no, because you can't have half numbers of neutrons. So what's going on? Well, relative atomic mass is a calculation that we do where we add up all the different isotope masses and their abundance, and we divide them by the sum of abundances of all the isotopes. So if you remember, every element has isotopes. Some just have one, but lots have more than one naturally occurring isotope with different numbers of neutrons. Some of those isotopes are around lots of the time, and some of them aren't around much. And so we can use this calculation to work out, if you like, the average mass of an atom of an element, and that's what we're trying to do when we calculate relative atomic mass. So let's have a think a bit more about chlorine. With chlorine, we actually have two isotopes that occur in nature. So there's chlorine 35, which has 18 neutrons, and 75.76% of the chlorine in the world is chlorine 35. But there's also chlorine 37 that has 20 neutrons, and that appears 24.24% of the time. So if we want to know the relative atomic mass of chlorine, we need to know the average mass of all of the chlorine atoms in the world. And so we can use our calculation I've just shown you, which is the sum of isotopic abundance times isotope mass number divided by the sum of abundances of all the isotopes. So this is what you would do. You would take the abundance of chlorine, which is 75.76. Now, you never be expected to know that off the top of your head. You'd have to be told in the question. And you multiply that by the mass of that isotope 35. We then add on the abundance of the other isotope here and multiply it by the mass of that isotope. We then divide it all by the sum of the abundances of all the isotopes. Now, if you think about it, that number has pretty much always got to add up to exactly 100. Sometimes because of rounding it might be 99.9 or something, but basically the bottom number is always going to be 100. So this is what you put into your calculator. Now just notice I've used two brackets at the front of the equation and two brackets at the end of the equation. If you actually have a calculator in front of you and don't put those extra brackets in, you'll come out with an answer of 6,000 and something, I think, which should cause alarm bells to ring, because clearly the average mass of chlorine can't be 6,000 if the atoms have a mass of 35 or 37. So when you put that into your calculator, you should come out with the answer of 35.48, and therefore if we round it to 35.5. Now in the GCSE periodic table, pretty much every element has a whole number for its mass, but chlorine and copper are slightly unusual because their mass comes almost exactly halfway between two numbers. It's shown in the periodic table as a half number. I should just say you might find in some places that the mass comes out as a slightly different number to that, and that's just because the numbers that you can use in this calculation are a bit more precise than the ones I've given you, but what I'm showing you here is perfect for doing well in your GCSEs. Now, practice makes perfect, so I'd like you to have a go at these two problems here. Use the equation that I've shown you and see if you can calculate the relative atomic mass for neon, and then have a go at bromine as well. It is really important when you revise to practice, not just to watch these videos and do nothing else with it. So press pause now, and then I'll show you the answers in a second. Okay, so this is the calculation that we would do for neon as I showed you before. So we do the abundance times the mass, add all those up, divide by 100, and that should give you 20.2 as the relative atomic mass for neon. And then for bromine, perhaps a slightly more simple calculation because there's just two isotopes. Put the numbers in and you come up with a relative atomic mass of 80. Well, now you've watched that, perhaps the next thing for you to find out about is what is the electronic structure of an atom. That sounds like a thrilling topic, so check out that video. But for now, don't stop believing. I believe in you. You can do it. Bye.